So moving to the next question, that is question number 10. When a Celsius thermometer reads 90 degrees Celsius, a faulty Fahrenheit thermometer reads 190 degree F. The correction to be made in the latter scale is. So what is given? A Celsius thermometer reading was given as 90 degrees Celsius and a faulty Fahrenheit thermometer okay, 190 degrees F. So let us compare this with later. The correction to be made on the latter scale. So you have to compare the Celsius scale with the Fahrenheit scale. So which scale is correct value you have given you? Celsius scale is showing the correct reading. So let us substitute the same. Well, the general formula is thermometric reading minus LFP upon UFP minus LFP always remains constant. So for a Celsius scale, C minus 0 upon 100 minus 0 must be comparable with a Fahrenheit scale, that is F minus 32 upon 212 minus 32. So this gives C by 5 equals to F minus 32 upon 9. But given that the Celsius scale shows a 90 degrees Celsius correctly. So substituting the value of C as 90 degrees Celsius, let us see what is the value of F. So 90 upon 5 must be equals to 5 minus 32 upon 9. Okay. So 810 upon 5 equals to F minus 32, or this goes 5 ones, 6 fives, 2. So 162. Okay. So if the value of F minus 32 is found to be 162, the value of F must be equals to 162 minus 32 if taken other side will become 32, and hence the value of F is found to be 194 degrees. So the Fahrenheit scale must show a reading of 194 degree F, whereas according to the question, they gave that the faulty Fahrenheit thermometer shows a reading of 190 degrees. So this must be the actual reading should be this value. But the faulty thermometer reading is 190. So what must be the correction that to be applied? So if for 194, if you subtract 4, then we are getting the value as 190. So how much correction should be made to the given question to get the value of 190? So 4. Hence, the correct option for this is the 10th question. It is plus 4 degrees Celsius. In the reverse way, to make you understand, if 190 they have given, if you add 4 to this 190, then you will be getting 194. So because the minus and plus everything was given, so to make you clear, so the reading, the reading that the faulty thermometer was showing is 190. So how much added or subtracted to get the correct value? This is the question. So we have to add 4 to get the correct value. Hence the correct option is plus 4 degree F. So this must be the correct value. You have to add plus 4 degree F to get the value as 194. So moving to the next question, children, question number 11. On a hypothetical scale A, the ice point is given as 42 degrees and the steam point is given as 182 degrees Celsius. So some unknown scale was given whose LFP as well as UFP were given, and the name of this scale they have named it as some A. Similarly, for another scale B, the ice point is given as minus 10 degrees and steam point is given as 90 degrees. So, second scale also LFP and UFP were given. The reading on the B was given as 60. So, we are asked to find the reading on the scale A. So, you have to compare these two scales. For any scale, we know that the thermometric reading minus LFP upon UFP minus LFP always remains constant. So, on the scale A, let us consider the thermometric scale reading as A itself. Instead of X, let us consider it as A itself. A minus ice point on A is given as 42. So, LFP on A is given as 42 upon steam point on A is given as 182 minus again ice point is given as 42. So, this should be comparable with a scale B. So for a scale B, let us consider the thermometric reading as B itself, whose LFP is given as ice point is given as minus 10 degrees. So I have to replace minus 10 degrees upon UFP is 90 degrees minus 10 degrees. Got it, children? So B minus LFP upon UFP minus LFP, where LFP itself is given as minus 10. Hence, solving this, A minus 42 upon 140 is found to be B minus and minus will become plus upon plus 10 upon 90. Again, minus and minus will become plus 10. So solving this further, we have A minus 42 upon 140 is equals to B plus 10 upon 90 plus 10 is taken as 100. Okay, so 0 and 0 gets cancelled, children. But we know that the value of B reads it as 60 degrees. So since the value of B is given as 60 degrees, substituting there, we have A minus 42 upon 14 is equals to B plus 10 upon, B should be replaced with 60. So 60 upon 10 upon 10. So finally we have A minus 42 is equals to 60 upon 10. 60 plus 10 is 70. 70 upon 10 is 7. So 7 and 14 if you bring here, it will become 4. So 70, 60 plus 10, 70, 70 upon 10, you got it as 7 and 14, bring it here, 7 times of 14, that's it. So A is equals to 7 times of 14 is found to be 98, and if minus 42, bring it to the other side, this will become plus 42. Hence, the final value of A is found to be 140 degrees. So what is the final answer, children? So the thermometric reading on the scale A is found to be 140 degree. Okay. So let us move to the next question, that is 12th one. A centigrade and a Fahrenheit thermometer are dipped in boiling water. So we are given two scales. One is centigrade scale, the other is Fahrenheit scale. So both were dipped in boiling water. That means, so steam point. The water temperature is lowered until the Fahrenheit thermometer registers 140 degrees. So now what is the reading that is observed on the Fahrenheit scale is 140 degrees. So what is the fall in temperature as registered by the centigrade thermometer? So the reading on the Fahrenheit scale is given. You are asked to find the reading on the centigrade scale. So the first and foremost you have to compare the Celsius scale with the Fahrenheit scale. So comparing the relation, we have this C minus 32. Okay, sorry. Centigrade scale, no? So centigrade scale with Fahrenheit scale, if you compare, C upon 5 must be equals to F minus 32 upon 9. This is the generalized formula. Okay. So now both are dipped in boiling water. So boiling water means C must show 100 and F must show 212 value. So whatever be the case, let us so you're asked to find the fall in temperature. So delta value. So difference in the temperature you're asked to find out. Not directly C. Difference in the temperature. Delta C and delta F. Because here also it was given that the water temperature lower and the Fahrenheit thermometer registers 140 degrees. So difference in the temperature is now found to be 140 degrees. So properly finding a fall in temperature on Fahrenheit scale. So listen carefully, children. Fall in temperature of a Fahrenheit scale. Okay. Whose value is given as delta F. properly listen, children. This is a little different condition. So delta F and this must be equal to, originally at boiling point of foreign heat scale must be 212 degree F. Okay. And how much it has fall down? It reduced by 140 degrees. So what is the difference you found to be? The value of delta F is found to be, this is 2 and this is 7. Okay. So how much is that, children? 72 degrees. The fall in temperature on foreign heat scale is actually, when it was kept in boiling point, it should show 212 degree F. But how much it has fall down? 140 degrees Celsius was fall down. So what is the difference? So the difference is 72. So now it is showing 72 degree F. Okay. So now we have to compare the same with the Celsius scale. So no doubt that instead of this we can say that delta C upon 5 must be equals to delta F upon 9. So 5 times of the difference in Celsius scale must be equals to the 9 times of the difference in that foreign heat scale. Hence, substituting, we have delta C, you are asked to find out, upon 5 is equals to delta F. Just now we calculated it as 72 upon, it is 9. So as we know that 9, 8, 72, hence the value of delta C is found to be 5 times of 8 and that is equals to 40 degrees. Therefore, the correct option is 40 degrees. So, second option must be true. Clear, children? So, what is the correct option? The fall in temperature on the Celsius scale is found to be 40 degrees. So, let us move to the next question, that is question number 13. Okay. So, in the question number 13, it was given that the correct value of 0 degrees Celsius on the Kelvin scale is. So, what is the correct value, children? It must be 273.15 degrees Celsius. And direct answer, the correct value of 0 degrees Celsius on the Kelvin scale is equals to how much? 273.15 degrees C. That's it. We have already discussed in the first problem. So, moving to the 14th question, a correct thermometer in foreign heat is introduced in a water bath. So, proper thermometer was given and it was dipped inside a hot water bath. So, steam point with a Celsius thermometer. The reading observed are 86F and 32 degrees C. The correction to be made to the Celsius reading will be. So, correctly, foreign heat is giving the correct value. So, Celsius, some mistake is there. So, how much correction? So, we have already solved this method. So, which one is the correct value? Foreign heat scales gives the correct value. Hence, so comparing only foreign heat scale, we have F minus 32 upon 212 minus 32 must be equals to. This is the original foreign heat scale. Okay. For the given values. Yes, 86 degree F they have given, nothing else was given. Yeah. Comparing with the original Celsius scale, we have C minus 0 upon 100 minus 0. But given the value of F as, the correct value of F they have given as 86 degree F. Substituting in the above equation, we have 86 minus 32 upon 180 must be equals to C by 100, or simplifying further, we have this goes 5 times and here goes 9 times. Therefore, the value of C is found to be 6 minus 2 is 4 and 8 minus 3 is 5. So, finally, we have 54 degree. So, 86 minus 32 is found to be 54 degree upon 9. Okay. So, this subtraction we are getting 54, denominator we have already 9 and bringing the 5 other side multiplied by 5. So, further simplification gives 9, 6, 54 and hence the value of C is found to be 6 5s 30 degrees. The value of C is found to be how much, children? 30 degrees. But what is this thermometer shows to be? 32 degrees. Given is 32 degrees and the reading that shows is 30 degrees. So what must be the difference between the given scale as well the original scale? It must be 2 degrees Celsius. So it must be corrected by 2 degrees Celsius. 32 minus 30, it is 2 degrees Celsius difference. So moving to the next question, children, 15th question. If a thermometer reading freezing point of water as 20 degrees Celsius and boiling point as 150 degrees Celsius. Some thermometer is given measured in Celsius scale whose ice point LFP is given as 20 degrees Celsius and steam point UFP is given as 150 degrees Celsius. So this is a Celsius scale and this should be comparable with a thermometer, an actual thermometer, original Celsius scale thermometer whose reading was given as 60 degrees. The value of C on the original thermometer reading is given as 60. So we know the formula that thermometric reading minus LFP upon UFP minus LFP always remains constant. So thermometric reading for that unknown thermometer, let us represent with X minus freezing point of this is given as 20 upon steam point or boiling point is given as 150 minus 20 must be comparable with the original actual Celsius scale, that is C minus 0 upon 100 minus 0. So from this we can conclude that X minus 20 upon 130 must be equals to C by 100. Okay. So, but children, we given that the value actual temperature was found to be 60 degrees. So, but the given value for actual value C is given as 60 degrees. So, substituting in the above equation, we have X minus 20 upon, here you are left with 13 equals to C, replace it with 60 upon 10. So, cancelling, we have. So, how much you are left with, children? X minus 20 must be equals to, bringing this 13 to the other side and multiplying with the leftover 6. We have 6 3s 18 and 7. So, 78. So, X is found to be 98 degrees Celsius. So, what must be the reading on the given thermometer, children? It must be 98 degrees Celsius. Okay.